A quick rundown of these gemstones. Again, the precious gems, kind of the big five, even though we included aquamarine. So the big five: diamond, clearly number one. Under types of beryl: emerald, corundum is ruby, sapphire, pearl. Those are the big five, but like I said, because we were there already, it's worth talking about aquamarine. And you saw that we left a couple of other things off. And obviously, outside of this realm, we have the semi-precious gems, which include, so many different types of things. Turquoise, and there's many different varieties of quartz that people consider gem quality. There's kind of purely translucent quartz we call rock crystal, or because they've famously crop out in the Rhine Valley in Germany, rhinestones, right? Those are just a type of quartz. Amethyst, which is purple quartz. There's a whole bunch of them here. But I only really wanted to focus on one because it's important to us in Idaho. Garnet, right? So we're going to explore garnet, and then we'll talk about there's kind of one specific garnet that's the state gem of Idaho. So garnet occurs, well, it kind of is a little bit all over the place. Generally, it forms these 12 or 24-sided crystals. So for you gamers out there, like a D12 or a D24, gamer speak. But they're spherical. And like I said, there's lots of different types. We'll talk about why in a second. But if we were to think about the most common type of garnet, again, if you go up near Riggins in Idaho and you know what beach to go look on, you can come up with handfuls of garnets. They're actually fairly common, particularly those that are kind of not necessarily gem quality, is that garnet has a chemical structure and as a result, kind of a behavior that means it loves to party. So there are lots of things that can substitute in the crystalline structure of a garnet. And that's not true for most minerals. So garnet, kind of additionally, one of the things that makes it useful is that it doesn't occur kind of as a product of magma interactions or something, or as magma crystallizes. It's actually something that forms under pressure, right? So it's something that forms in a metamorphic environment, right? Under heat and pressure. And because in that metamorphic environment, it behaves as an open system, it's actually getting kind of other atoms and other elements included in it as it's growing in those conditions, meaning it's basically taking like chemical samples as these tectonic and geological processes occur, which is actually why I've included here, because garnets are awesome. Oftentimes scientists will take kind of laser ablation and will zap a garnet in a transect from the core to the rim, and we might get some sort of chemical analysis that tells us when certain things were kind of included, how the conditions of that growing environment changed over time, and really the pressure temperature history of things like mountain building, right? These really big ideas. That story is largely told within garnets, which totally cool, but not so cool if you're not really interested in mountain building, right? Okay, so that's one of the things that makes geologists go gaga for garnets. But aside from that, it's also just really pretty, right? We use it for a lot of different things, at least in the kind of creative arts. So you can see here, this is kind of typical garnet, but like I said, garnet likes to party, right? It has all sorts of different inclusions, meaning it has a huge range of different things that we see as garnet. The kind of most common, the most standard is this kind of red, almost like ox blood red, like deep garnet red, I could say. Yeah, deep red, not quite purple. This is a type of garnet known as an almandine garnet. And like I said, they're far and away the most common. They're not necessarily the most sought after. You can see here, this is a group, kind of diagram showing lots of different types of garnet based on their chemical structure. That means they can show up in lots of different colors, different kind of crystal forms. Like I said, you kind of have these, you have these 12 or 24-sided crystals. So again, they're all over the place. Here we have a pie diagram of garnet sails. Again, garnets that are sold kind of in the gem market, I noticed that the large pieces of pie are not almandine garnet, which I said is the most common, but it's definitely not the most kind of gemologically pure, right? It's not oftentimes gem quality. The gem quality garnets tend to be these other types, which again you can see here. Obviously you don't need to go through this list, but I wanted to highlight how many different types of garnets there were. So one that's not included on that list that we were just looking at is what we call a star garnet. And a star garnet, surprise, has inclusions of this chemical that we've now seen a couple of times. Chromium. Oh man, chromium is what made emeralds emeralds, and it's what makes rubies rubies, as differentiated from beryl and corundum. But here, when we have a garnet that's included with chromium, it forms these kind of funky little structures within the garnet, and the result, once the garnet is kind of polished up, and oftentimes we kind of tumble these things and make them, this works best with star garnets, make them kind of spherical. When the light hits that garnet, the way that the chromium molecules kind of affect the way the light travels, it actually gives this kind of strange star-shaped reflection pattern. And that's where the term star garnet comes from. Like I said, that's an Idaho thing, right? That's our state gem. And they really don't occur very many places. So there's a known spot in India where there's a large number of garnets that have these chromium inclusions, and then also in northern Idaho. So geologically, there's part of northern Idaho that represents basically where continents were smashing into the craton. So kind of it was a subduction zone at one time. And the temperatures and pressures were sufficient enough to grow garnets. There was chromium in that environment, and because garnets love to party, they included chromium. And so in northern Idaho, there's garnets that are abundant. So this is a spot that you can visit. I believe it's a state park, Emerald Creek. And what they do here, you pay a fee to enter, and they take detrital garnets. So those are garnets that are in stream beds, almost like if I were to use the term placer garnets, like we learned that in our mining module. So garnets that have been eroded out of a rock face, the surrounding rock is decomposed. Usually it's a schist or filled with muscovite, something that will decompose fairly quickly. And then the garnets will wash down into the stream and be deposited in these kind of sand and gravels. And you can see in the back of this picture here, this is every morning they take a new scoop of material and dump it off. And if you've paid your fee to go to Emerald Creek, you can grab a bucket and go over and dig through and pull out garnets. Some of them are properly included with chromium. And people pull out garnets that are worth hundreds of dollars. Garnets aren't worth like tens of thousands, but people pull out garnets that they could potentially sell for a lot of money, but usually they don't do that, right? Usually you take it to a gem shop and get it turned into a bolo tie or earrings or something like that, right? You find this gem and you could have someone make something for you. Not too far from where Emerald Creek is, because garnets are fairly plentiful in that area, there are these kind of alluvial plains, sands and gravels, and we commercially extract garnets from those. One of the characteristics of garnet that makes them very valuable, so garnets are hard. They're a kind of 7 to 8, depending on the type of garnet, on Mohs scale of hardness, which actually is a kind of a mineralogical scale of hardness that goes from 1 to 10, diamond being 10, right, the hardest thing. But garnets are fairly hard as well, and because of that, we actually use them in industrial abrasives fairly commonly. We can powder garnet, make it into a garnet powder, and that is often included into the slurry that we use for water jet cutting. If you've ever seen really high pressure water jets where they kind of cut out delicate shapes out of sheet metal. But another thing that we do is we can kind of crush them up into defined sizes and actually just use them for sandpaper. So oftentimes you see this pink sandpaper, and it's garnet sandpaper, which is a little bit different than typical sandpaper, which is quartz. But quartz is also a hardness of 7, so kind of depending on what you're looking for, you can get different types of kind of industrial abrasives, garnet being one of those. Okay, well that's going to do it for gemstones. We made it through, again, the classics: diamond, emerald, we included aquamarine, sapphire, ruby, pearl, and then just for fun we threw in a 6th garnet, which doesn't actually make the list of kind of the classical precious gems. All right, we'll see you in the next module.